Right, so what we're going to be covering today, I said it was a big one. So Richard's just going to talk a little bit about who the flood products team is inside Jacobs. We'll talk about the challenges in the industry, and this is not just Australia and New Zealand, although that's my area of focus. This is what we've seen across the globe. We'll give an overview of Flood Platform. I'll show you a live demo, and if you think you've seen my live demo before, you possibly have, but I'll introduce some new features that have never been seen before, so that's exciting. I'll talk about the roadmap. We've got some case studies to share with you. So Flood Platform, although it's new to everyone outside of Jacobs, we've been using it internally for over 15 years. And Rich is going to talk about licensing and pricing, and then we'll get to our questions and answers. So Richard, I'll hand it over to you.
Thanks, Sophia. So, I'm sure a lot of you are aware of Jacobs as an engineering and consulting firm, one of the largest in the world. But we are also one of the largest that does flood modelling. We've got over 1,200 people who do modelling as their main job using tools like Flood Modeler, TUFLOW, HECRAS, EPA Swim, Mike, and InfoWorks. And we're one of the world's biggest holders of DHI software and InfoWorks software as well. But within our digital team here at Jacobs, we've got over 800 people who are contributing to the development and support of our digital solutions. Within the Flood family of products that we have, we've got over 32 dedicated software developers and technical support engineers supporting products like Flood Platform, but also Flood Modeler, that we've had for over 50 years and we've been developing. But the Flood Platform itself has been around for just over 15 years as a tool and has recently come to market for everyone to use. So it's something that places Jacobs in quite a unique position, not only just a user of the flood modeling software to deliver solutions for our clients, but also as developers of the tools, which enables us to kind of accelerate and innovate like perhaps many other software organizations can't. Sophia. Oh, no, next slide, please. So in my background, I've done a lot of consulting work and understand a lot of the frustrations modelers have and clients have. And a few years ago, we did an extensive exercise to reach out to the industry across the world and ask them the question, what were their challenges? Because we appreciated that the challenges that Jacobs had might be quite different to what others are facing. But it was quite common, really. And there was a number of key themes that came out, and one was actually how to manage the large volumes of modeling data that people get and trying to find things, and how to transfer models from one organization to another at the end of a project, but also at the beginning of the project. If you're building on a model that's been done by someone else, or you're collecting information, how do you transfer that data over to you apart from maybe a hard disk drive or putting it on a shared drive and checking that you've got all the files there? Becomes a bit of a nightmare. We did an exercise where one of our key clients provided us a lot of models recently, and we did the checks and reviews and found that a significant number of files were missing or models wouldn't run because not everything was there. And then also another area is when you're passing things around or multiple tools, you might not have the licenses to be able to interrogate data or models that are provided to you, or you've got to use different plugins to visualize stuff or whatever, or you've got to find somebody else who's familiar with a piece of software that you're not. We also found that lots of people were developing their own automation tools to speed up things, and that was happening within the same organization. Different pockets of people were doing kind of the same thing, but in different ways, and they were spending a lot of time and money trying to get that to work and keeping it up to date. Perhaps the biggest challenge that everyone was coming about was the collaboration, certainly on modeling results. And not only just with clients, but within their own internal team. So when you develop something and passing a result on to someone just to do some checking or get some feedback, people were using Word documents, Excel files, just to try and track things. And it's a very difficult and challenging problem. And lastly, is actually access to licenses in some instances and the compute resources to do things. Certainly when you're up against a deadline and having to do hundreds or in some cases thousands of simulations very quickly. Being able to get the resources to do that, and some organisations are setting up banks of computers that were just sat there waiting for those days where they had high demands, and others just had to string it out over several weeks and months. So these were the challenges everyone was telling about, and when we realised that Flood platform that we were using was solving most of these problems out of the box, we thought, well, it's something that the industry needed to get hold of, and that's what we've done. Sophia, next slide. So, who have we designed Flood Platform for? Well, there's many different users. The most obvious one is actually the flood modeler, the person who's doing the work themselves. But when the flood modeler is kind of working with their peers or working with their bosses or reviewers and subject matter experts, they need to be able to pass models work to them and to work with them. So there's tools there to enable them to work together. There's the technical manager who wants to keep oversight of what's going on, wants to make sure that everything's happening efficiently, that model files are passing around, can understand and share things with the client to make sure that the clients are happy. It helps with the senior technical managers. There's those on the client side, which could be the flood risk manager or the planners and development assessors who want to see the outputs of the modeling or just want to be able to share things across their teams and so forth. So there's very different groups of people that Flood Platform out of the box is designed to work for and solve the common problems that they all face. Sophia, back to you. Is it back to you? No, it's my one. Okay. So a bit of a description of what Flood Platform is built around, the sort of framework that we have in place. So at the top here, if you think about it, you've got your clients that you might be working for, you've got your modeling teams, and you've got your stakeholders, and those stakeholders could be both internal and external. Then you've got kind of all the building blocks or the toolkit that you've got available. So you've got your model management features and modules. You've got all your visualization tools that you've got there. You've got everything to help you with collaboration in a secure environment, only enabling you to share things that you want to share, whether it be spatially or time bound or with particular groups of people. You've got all your simulation and analysis that's available. And you've got some reporting there already, but there's a whole load more reporting coming too with the AI tools that we've got and automations. And that's built with a layer of storage. So you've got elastic storage to kind of store whatever you want on there in terms of modeling files. And then you've got your compute. And your compute can range from CPUs to high performance GPUs on demand. And that's built on the Microsoft Azure framework. It is intended to be one platform to bring all modelers together, irrespective of the modeling tools that you use. It already works with Flood Modeler and TUFLOW and Flood Modeler TUFLOW results. The internal version that we've had in Jacobs for many years works with HACRAS and EPA Swim soon for many years and is coming soon to Flood Platform. And we'll be expanding it to other tools as well over the coming months. So that's enough about perhaps talking about it and what it stands for and what the problems it's trying to solve. But let's have a look at what it actually looks like. So I'm going to pass back to Sophia to give you a live demo of the platform. So back to you, Sophia.
Thanks, Richard. I'll just bring my web browser over to the main screen. So this is Flood Platform, and Richard, I'm sure you'll be happy to see that the global view is front and center. So this is something that was pretty important to the team, especially in Jacobs, where we are a global consultant, where we do projects all over the world. So being able to find where we've done modeling projects, make sure that we can leverage what's already been done, or perhaps if a client is looking for something, we can find those projects for them. So what I'm going to do is I'm just going to zoom into where I am today, which is Tweetheads. Right. So you can zoom in, you can find projects. If you've got them in the list, you can also find them in the view. So I'll just zoom out a little bit. So you can see that I'm based on the southern end of the south side of the New South Wales and Queensland border. But there's lots of projects that have been set up on the Queensland side. So if we wanted to find out what kind of models have been set up, we can select one of these areas. It gives you a little bit of information about it. So this is the Nerang River catchment. And I can drop down there and you can see there's no models available. So someone set up the project but actually doesn't start doing any modeling yet. If I select my area, just the north of the Pacific beaches, and I come through here, you can see that there's actually two projects or two models within that project. So I've got Kira and Tugun. So if anyone from the Gold Coast knows the area, we've got Kira down on the southern end and Tugun further up here. And I'm going to select one of those to kind of interrogate a little bit further. So as kind of all web apps, you can actually hit the control key and select on anything to open up a new web page. It's one of the nice things about Flood Platform. It's pure cloud native, web native. So no installs needed. So I've just opened up this particular project model, and you'll find that the models have been split into 3 different categories. So you've got the simulations, the model files, and then also the upload checks. So I'm just going to go through these one at a time and just show you what they are. So you can see here I've got some simulations. So what Flood Platform does is when it receives a flood model, and in this case it's a TUFLOW 1D, 2D model that's been zipped up, I've got some models that have actually had results inside that zip file. So Flood Platform's kind of found those models and given us 100% run progress because it's everything's available. I've also got some already in the queue that don't have any results ready to go. And what I'm going to do is just add a few more to the queue. So for example, I've got some results for the 15 minutes. I wanted to go and get some results for the 30-minute duration. I can select those and add them to the simulation queue. So this was the feature that's brand new, never been seen before. And this is really for modelers or for people who are receiving models who we often don't keep the result files of the models because they're so large. So you can keep your model, and if you need access to those results, you can come in here and quickly run it and access those results. So Flood Platform's gone and sent all of the simulations to the queue, added them to the list for 30 minutes there. And what it's gone and done and made sure that I've got all the files that I need to run those simulations. And also we need to check, do I have any simulation credit? So we do charge per simulation. So if I go and hit, if I select some to run there, I can run the selected. So you can actually run, you can add a heap of simulations from different projects to the queue and then run them once you're ready. So it just goes and checks if I've got enough credit, past that, and then it'll send them all to be run. So Flood Platform gives a dedicated resource to each simulation, and they're all running in parallel where possible, so that you get the fastest return of results. I'm not going to run those yet because Richard's looking, and that'll be charged to his budget. But I'll just go back to the model that we had. So that's the simulation. So we'll have a look at the result files shortly. We can also look at the actual model files that have built the model. So I'll just go to the run first. In TUFLOW's case, usually the control file is the most important file. And you can see without having to install Notepad and all the color schemes or the syntax, not having to do Excel, not having QGIS, you can visualize all these results in Flood Platform. You also don't have to download anything, which is nice if you've got things stored in the cloud. So you can see all the files there. We do support HPC. We also support GPU. And I learnt recently that this is the worst combination you can have, HPC with CPU. So any modelers on the line, here's a hot tip. If you're using CPU only, make sure you run Classic because it'll be much faster. And we also, anything that kind of TUFLOW supports, so the subgrid sampling, the quad tree, everything's there supported inside Flood Platform. The only thing we don't support that I know of is the geo package. So we've got shapefiles and MIDNIF supported at the moment. You can also look at the individual files that make up the model. So I've got the materials layer here, which shows you all the information without having to open up Excel. And if you had a bigger file, you could go through and search for things inside there as well. And the last one there on the list is the upload checks. So when Flood Platform receives a model, it goes through and actually kind of breaks it down and rebuilds it from the batch files and all the information that it has. So it goes from both ways. It looks at the batch files and all the simulations, and then it also looks at all the results and kind of marries them up in between. So if you've got result files that don't have a simulation attached, you can still view those results, but it will tell you that the simulation's missing, and vice versa. These checks here that I've got is actually something in the model is missing to be able to rerun the simulation, or something that's been listed in a file somewhere, even if it's commented out, is missing there. So you can see that I've got some shape files that it hasn't been able to find. So a good modeler, if you're going to hand this over for review or you're going to hand this over to a client for storage, you would make sure that all of these checks have passed. So I would have to go and do a second iteration on this. Also, if you are someone who's receiving models, this is a great way to find out and make sure that your consultant is giving you all the files you need to rerun those models at a later date. Right, so I'll flip over to the simulations now and just show you some of the results that we have. But I'm just going to pick a little bit more of an exciting model to have a look at. My Kiro demo model is very small. So here we've got the Queanbeyan 1D, 2D river model. And you can see it's been run in HPC GPU, Classic, and the HPC CPU. So depending on what you use, what engine you use, and what configuration, you'll get a slightly different summary table or view, because different information is useful for different types of simulations. And obviously, if you're using Flood Modeler, you'll get slightly different values as well. So you get the information about the simulation, so the time steps, what solution scheme was used, what hardware was used, and then the information down below is all about the simulation kind of health and also what's happening. So in a HPC, you kind of get the time step here, which is a really good indication of whether it's healthy. You can also have a look at the values down here to see what's controlling that simulation time step. And really quickly, you can see kind of, it's in this model, the simulation, the inflows have kind of finished and the flows are receding because you're getting less wet cells. It's just a really nice way to make sure that you kind of reach the peak of the simulation as well. If things don't go as well as you expected, you can always have a look at the input file and make sure you've got everything you need. And if you're a little bit on the nerdy side and you prefer to look at the log files rather than the summary page that we've created, you can. So we have all the different log files out of the TUFLOW that TUFLOW kind of creates. You can review these manually. You can also use the search command. So I found that if you type in volume, you get to the bottom of the log file pretty quickly. So you can show kind of all the information that's shown on the summary page as well. You also get what's happening pre and post simulation. This is more about troubleshooting if something goes wrong, but you can go and have a look at what's actually happening behind the scenes in Flood Platform. So I'm just going to go and have a look at the actual results now. So this is the nice map view inside Flood Platform. So you've got two options built in. You've got the street view or the aerial view. This is my personal preference, but everyone has their own. And I'm just going to turn on some information about the model. So this is one reason why I use this model is no one wants to build a 1D channel model inside TUFLOW in Australia, including myself. So I've used one that's been built by the UK, but we've got a 1D channel here, some 1D pipe culverts here, and also the river, the main channel, is being represented in the 2D. So I can turn on the depth raster then, and you can play through the simulation. You can also change the transparency. So if I play through the simulation there, always a good thing to do when you're reviewing a model. And we should start to see some flows. So you can see the flows coming out of the culverts and also from the two upstream boundaries. And then we have a downstream boundary further down here. So you could also just turn on the maximum values as well. And then you can kind of move around the model without that moving on you. If you want to have a look at the 1D results, this is quite new as well. So you get your pipe culvert view, so the information about the actual culvert. Plus you can have a look at the graph, so you get the upstream and downstream elevations and the flow all in a single graph. And you can also, if you're not using the maximums, you can play through that simulation and it's all integrated in the views. So you'll see the bar on the graph move plus the flows through the culvert move. And that also works on the 1D channels. So if you're brave enough to do 1D modeling in the channels, you get really nice results there of the channel profile, the water levels. So if you're reviewing a model, obviously you'll have a look at the results, but some other things that you might want to look at. So you've got all your common check files, anything you kind of turn on inside TUFLOW to create the check files you'll get. And you also get any messages that are in the log file. So I'll turn that one on. And you can see there, got some messages. So I'll just select one of those. And you can see there it's just a warning about the drop in elevation to match the 1D outlet there. So always good to go and review your messages as well. Now, if you are a modeler, you might want to go and interrogate more things on the model. So you can actually go and have a look at your 2D code layers. You can look at your different boundary conditions, and you can also look at your cross sections. So everything that's kind of been used to build the model, you'll actually have available inside the model files as well. Once you review that and you're happy, or perhaps you're not happy and you want to create some comments, you can go to the comment icon, and you can see there I've made some comments already. And if anyone else had already reviewed this, their comments would show as well. But I'll just create a new one here. Right, just to check the message layer. And that's how you create comments. So in the future, I'll show the roadmap shortly, but these will be threaded. So you'll be able to have a conversation with your team modelers or your reviewers to make sure that everything that you need to review in the model is reviewed and kind of checked off. So that's it for the results. You also can actually export them if you want to a PDF. But now that they're in Flood platform and they're available on the web browser and on your phone or iPad, I can't see why you would want to do that too much. Save the trees and keep it all online. But once you've finished your modeling, you're happy with the results, perhaps you want to hand that over to your client or you want to store that somewhere outside of Flood platform for any reason, you can actually do two options. You can export a single simulation. So that would just be the model files that created that simulation plus the results. Or if you wanted to go back to the model, you can export the entire model. So that will give you the model plus all the results for all the different simulations. So if you wanted to do some post-processing that we don't support yet, you can go and do that manually and then reload, upload everything that you need if you needed to. And if you wanted to actually share that with someone without having to do the downloads, you can just go to the settings and the members tab, and you can add a member here. So I'll just put in my personal email address. I can invite the user. This can be anyone inside or outside of your organization, which is really nice. And you can see there I've been added as a viewer. So I can go in from my personal account, go and view everything inside that project if I want to. We can obviously always remove access. If you wanted to give a higher level permissions as well, and that account had access and a license, then you can set different levels of access. So there's admin, member, and the viewer, which was what I was. So I think that's it for Flood Platform. Such a simple tool, but so powerful. I will flip back to the PowerPoint deck. and we'll have a look at what's coming next. So on the roadmap for the rest of the year is kind of fine-tuning the features that are already available. So we'll be adding context mapping. So when you have a look at the results, you'll be able to add extra GIS data to give you context of what you're looking at. So perhaps road designs or flood extents that you've been looking at for something else. We are adding in threaded comments, as I mentioned earlier, to give that full picture and kind of close the loop on any modeling problems that we have. We'll be able to upload missing data separately. So at the moment, anything that doesn't pass the process checks, you need to kind of package up the model again and have another go. But we'll be simplifying that so you can just upload something missing. We're adding post-processing. So if you're doing pre-verse post or you're doing ensemble analysis and you need to kind of do those post-processing tools, they'll all be built within Flood Platform. We're also looking at advanced version control. So at the moment, Flood Platform is quite simple. It kind of just tells you which is the latest version that you've uploaded to make sure that you're always looking at the latest model. But in future, we'll be able to, once we start editing and uploading data, there will be tracking the version on those models to make sure that we've got full granular versions on that. And we're looking at more QA tools. Next year, lots of exciting things coming. The one that's most exciting for me is actually the sim builder. We've been talking to lots of different people, and depending on how long you've been doing modeling for, kind of varies of how important this one is. But lots of people hate running or writing batch files or reading other people's batch files. That's something we've been doing a lot of lately of testing Flood Platform is we've seen so many different variations of the way people write their batch files. So we're going to be writing a nice UI so that we can do all of that really easily inside Flood Platform. And for anyone who hates writing batch files, your days can be over for that. And the other one there is 3D views. I think that's something that's really important, especially when we're trying to relay flood information to people that are non-technical. Nothing better than a 3D viewer for that purpose. And then, of course, for anyone who's joining from the US, EPA SWIM and HECRES support is on the roadmap as well. All right, so moving on to some case studies. As we mentioned, Flood Platform's been used inside Jacobs for a long time. So plenty of case studies to share. But this one's, I've seen this going on a lot since I've been at Jacobs for the last 9 months. But the Melbourne Water Flood Mapping Project. Flood Platform has been used a lot for that. So as part of the Greater Melbourne Flood Information Program, Melbourne Water is delivering the 2021 to 26 flood mapping program, which aims to provide comprehensive flood mapping for all the municipalities across Greater Melbourne and the Western Port region. And they're doing that using the latest flood modelling standards. So if you are a flood modeler at the moment, you know what that entails. So Jacobs was engaged by Melbourne Water to support the development and the enhancement of flood models and mapping across several of the catchments. And Flood Platform was used to deliver the projects successfully and in a timely manner, despite having to run thousands of simulations, testing all the different AEPs, durations, storm patterns, climate change scenarios, and different scenarios in accordance with R&R 2019. And I should mention there, being able to use Flood Platform and parallelizing those simulations took what would usually take several weeks in traditional methods, just days. So over into Richard's hometown, we've got the Oxcam ARC project. So this is a project in an area that links Oxford and Cambridge. And if you see it on a map, it actually does look like an arc. But essentially the client needed to optimize investment in flood defences over a 30-year period to be able to unlock economic growth in the area. So they're looking at building 1 million new homes, plus lots of infrastructure to support those houses and those people moving in. One thing that's quite unique about this project, which I've seen now and then, but definitely not on every project, is they didn't just look at different scenarios, different implementations of flood defences over a 30-year period. They looked at implementing it in a staging or a phasing approach where they looked at what would happen every 5 years. And so if you think of lots of different flood defense options in a 30-year period, and then you stage it over a 5-year period to optimize the expenditure, the number of simulations that you need to have a look at just blows out crazy. And in the end, Flood Platform was used to configure 900 Flood Modeler and TUFLOW, so they were 2D models of the study area. And they ran 45,000 simulations to test all the different scenarios and climate change futures. So, small amount of simulations. And the last one there is the Thames flood mapping, hot off the press. I will pass it over to Richard to talk a little bit about this one.
Hi, Sophia. Thanks for that. So, yeah, the Thames Flood Mapping Project, you're probably familiar with London, and it's quite a large value asset for the UK, and it's defended by the Thames Barrier. The Thames Barrier is actually getting towards the end of its life, and the UK government is looking at how it needs to upgrade its flood defences for the City of London. There's over 1.4 million people, and over 300 billion pounds worth of property at risk in the London area. It's a highly complex system with lots of tributaries, structures. You've got tidal flooding. You've got lots of storage upstream as well. So and lots of defences along the River Thames. There's an Act of Parliament that protects London to the 1 in 1,000 year flood. But with climate change, that is rapidly eroding, and new defences and a new way of managing flood risk needs to be put in place. So a new flood risk mapping exercise needs to be undertaken, and the UK government have appointed Jacobs to undertake this. And it's going to require in excess of 250,000 simulations to be run. And these aren't necessarily short simulations, they're highly detailed models that will be required. Anywhere between 1 and 3 meter grid resolutions typically will be required in 2D. There's a large team delivering this. It's not just Jacobs, we've got partners. So there's a lot of collaboration between the delivery team and also with the client. A team or a solution like Flood Platform is key to delivering this. There'll be a significant amount of volume of storage. There's models that need to be passed around from the client to Jacobs and our partners to deliver this. So it's providing a robust and streamlined way, not only just to transfer data, store data, and do the simulations, but deal with the whole stakeholder management. And this is a project that we've only recently started. And the client said they chose the team to do this, which is led by Jacobs, because of the technology behind it and the complexity that was needed. But the same technology is being used for every other project that Jacobs is delivering and some of our partners. So thanks for that. I'm moving on to perhaps pricing, which is one of the most important things I'm sure you'll be interested to hear about. It's the most common question that we get. So there's 3 flavors of our Flood platform. There's the viewer license. Oh, gone on too soon there, Sophia. We've got the viewer license, which is for free, and it comes with both the core and the advanced. We get a number of those thrown in. So if you're sharing results or collaborating with others, they don't need to buy a license. They will get some viewer license on the back of your other core advanced seat that you get. We pay, or you pay on a monthly basis per seat. The core is $450 and the advanced is just $550. There's a number of nice features that you get with advanced coming along soon, including AI and analytics and stuff like that. But not everyone will need, but the core will probably meet 90% of people's needs. So once you've decided on which seat you want, I think most people go for the core or are going for the core, is you need to buy some storage. And you buy storage by the terabytes, like you do with any other, you can say, data storage account that you may have. You decide how much you need and how much you want for your team, and you pay by the month. And that's currently just under $30 per terabyte per month. For your first 25 terabytes, and if you want more than 25, you can get discounts on that. And then in addition to that, you'll need some compute credits to be able to display everything within a web application. We've got to do a little computing and fantastic data analytics to be able to do that quickly. But also, if you want to do simulations, you need to be able to pay or buy compute credits for that. We sell them in $1 increments, but it depends upon the type of simulation that you're doing. So to give you an example, if you're using the TUFLOW S3 model that Sophia was talking about before, and you're using a GPU for that, and you're doing 100 simulations that take 30 minutes each, you're talking maybe $60 to do all of that in 30 minutes. So it is relatively cheap. It's certainly cheaper than what you can get if you go and buy compute from Microsoft Direct, because we partnered with Microsoft to be able to get these prices and make it as affordable for everyone. So typically, it's less than a cup of coffee to do half a dozen runs or even a dozen runs. So how do you get up and running for this? Well, you can get in touch with us to do a trial, or even jump straight in and to buy it. We've got a whole team ready and available to deal with onboarding. Our team that have been working on Flood Modeler for many years are very experienced in supporting teams, getting them running. We've got step-by-step guidance to get you going quite quickly. But I must say the user interface is pretty intuitive, and we believe everyone should be able to get up and running very quickly with this, with very limited knowledge of modeling. We've got a dedicated support team that runs almost 24/7, I would say, because we've got a global support network from Australia all the way to the UK, and some resources in America as well, and India. So it's a global footprint of support to help people. There's a whole array of training for you there that's interactive, so you make sure you get the most out of the platform. There's some sample data as well there, so you can play with things. And as Sophia mentioned, as the roadmap, there's continuous improvement in the product. It is being developed continuously, and we are putting out regular updates of the platform. So you're always going to be getting the very latest in technology and innovation.